Okay, hello. Nice to meet you. I'm Takayoshi Koizumi from Japan, Sony Semiconductor Solutions, and I'm working for Spresense. It is kind of the first trial board from Sony, this kind of the microcontroller board, development board. And today this session is final session today. Maybe you must be tired already. Honestly, I'm tired. Very, very hard jet lag right now, but I'm hanging on. So I hope you enjoy this hands-on, hopefully. Okay, let's start. So before to start this session, please confirm the preparation for this handset. We delivered 3 boards. One is white-black package board, and it's a main board, Spresense main board, and whole white box is extension board, and pink back. Plastic back is Wi-Fi add-on board. So these 3 is delivered. If you anyone don't have these 3 boards, so there is a board list. So please go to take them. And also, before this workshop, I request you to bring some things, 2 micro USB cable and 1 micro SD card, and earphone if you have, and Linux PC. So this today I will explain the hands-on by using the Linux PC. So. Please use the. If you can, of course, you can use Windows or Mac, something else. But I will explain based on Linux. Sorry. And software on PC. Of course, the NuttX normal build environment. You already said, I believe. And the MKSPK2. This is a kind of the Spresense. The binary converter, and bootloader firmware. This is kind of the bootloader for the Spresense, the binary code, and source 3 for hands-on. Then original NuttX and NuttX apps and the Spresense SDK. So please these should be confirmed to download it. This material is, I think, already sent you guys from the Dave-san just a couple of hours ago. And so if you see this, how to say, please see the material to confirm and access to this kind of the website. Thank you. So, so today's agenda, I will just introduce some Spresense board, and the CXD5602 is kind of the IC chip for the Spresense, and also we almost not all, but almost technical information is open. So I will introduce the documentation side, and also the right now our nice member is upstreaming to the NuttX original GitHub. So I will explain the kind of the summary of the status of the upstreaming the NuttX right now, and start the hands-on the NuttX. First, using the NuttX, original NuttX, and after that, I will show some demos by using the Spresense SDK. And at the end, I will explain some feature plan for the upstreaming. Okay, so this is Spresense, provided from July last year, so just 1 year old of the Spresense. The first was provided in Japan, and right now in Europe and US, you can buy it by net distributor. And this board has 3 special functionality. The one is there are the multi cores, 6 cores inside. The core is Cortex M4F, and next one is the audio. This board can handle the high resolution audio, and not only the output, also the input. Input channel is 4 analog channels or 8 digital channels microphone exists, and 2 output stereo audio. There are not only the digital signal, but also the Class D full digital amplifier is inside. So I believe the output audio quality is better. I think. I hope. And position feature that is GNSS. The supporting satellite, the GPS, GLONASS, and QZSS is kind of the Japanese satellite. For the hardware, this can support the Beidou and Galileo also, but right now, because of the firmware's implementation, I'm sorry, the Beidou Galileo is coming soon. Okay, and internally the SRAM has 1.5 megabyte, and flash memory is 8 megabyte. But this is just SPI flash. So and digital I/O's analog input, usual microcontrollers interface exists, and other things. Camera interface also has it. It is a parallel camera interface, not a MIPI like, because of the power consumption we didn't select the MIPI interface. So this is a board configuration. We provide you the one is the main board. This one has processor main chip and power management chip and interface. And especially the I/O interface voltage is just a 1.8 volt. And this extension board is kind of the breakout board. And this one is made for easy to use audio functionality, like a headphone jack here and SD card and microphone pin header. And also, I/O voltage is converted to the 3.3 or 5 volt. So easy to existing the other board to connect jumper in by using this board. And also, we have a camera board right now. I'm sorry that today you don't have a camera board, so please buy it. And Spresense has 2 chips made by 2 chipsets. So we are the Sony Semiconductor Solutions, and actually we developed these 2 chipsets. The one is the digital part. The right side 605602 is digital part. This includes low-power GNSS and merge processor, high-resolution audio, and the camera interface, and so on. And the left side is the analog part, the power management, Class D amp, and microphone interface, speaker, and the battery charger. Actually, this chip can support charging functionality, but for this Spresense board, we disabled because the charging function is a little bit dangerous for the beginner user, so we disabled it. So, and this is kind of the 5602 main chips block diagram. So there are 4 parts. The one is red part is application domain with it, and the 6 cores is in this red block. Here, and the 6 cores over there. And other some functional interface exists, and 1.5 megabyte SRAM is also in this block. And year 1 is system and IO processing domain here. So actually, I said this Spresense has 6 cores, but there are 2 more cores, 2 more processors here. And this one is Cortex M0 based. And this one, this guy will handle the boot loading or security. Actually, this chip can support secure boot. So this guy will handling that kind of the system management. Not only the security, but also power management also. And GNSS core is here. So GNSS is an independent system in this step. And sensor domain here. I will explain, sorry. And also the flash memory is interfacing the SPI flash controller and here. And SPI flash file system is actually, I said, for 8 megabyte SPI flash on the board. But there are 2 partitions. One is Sony original file system to store named SPK files. This is kind of the executing the binaries on the Spresense. And other 4 megabyte is free area for user. And by using the NuttX by Spresense SDK, Smart FS is by default for the NuttX right now. And also, let me explain a little bit deeply about the sensor domain. So this is a kind of the one of the how to say the original function. So this is kind of the intelligent internal sensor hub, like a sensor hub, but not only the sensor hub. Let me explain. So yeah, so there are 3 blocks overview. The one is interface to the sensors, and one is sensor engine and file for block. So the sensor engine has 2 parts. One is a sequencer to pull the sensor data from the outside sensors, and the other side is the IR filter, to make it to change the data by using this filter, and FIFO, and the DMA controller, and also there is the event detector here to interrupt to the CPU to wake up the CPU. And so how to work about this is the sequencer will, as I told you, pulling the data from the sensors without CPUs. So the pulling itself is very lower power by using the compared with by using CPUs, and just pulling the data and go to store the FIFO and make the watermark, and after watermark, then the CPU wake up. That is kind of the sensor hub. But it's not only the sensor hub, I told you, but because there is an IR filter here. So two-stage IR filter exists, and this is a two data paths. The one is FIFO, data store, and one is event detector. And so there are 3 points for 3 places to put the IR sensor, IR filter. And 3 or 2 can be put, or of course the the pass-through also can be selected. And after this using the filtering, IR filter, then the event detector will detect some signal. For example, if some signal is coming and use or not use the IR filter to the event detector, if you get some kind of sensor signal like this, and if the sensor signal, how to say, characteristics is like this, then the wake up the CPU. So this kind of mechanism can much more filtering and to reduce the waking up the CPU period. So this mechanism is for much lower power to use just a CPU. That is a sensor domain, sensor control unit we create. So, and Spresense software stack is like this. Right now, we're using the NuttX version 7.22, bit old. And right now we are catch up in the newer version. And documentation. There is a Sony developer world site, and software document. Every software document on this site. So if you think about something, questions, first please visit here. And also the hardware documents. Board description is also the same website, different pages, and board schematic on GitHub. And very fresh information. Just today, finally, we opened the chips user references. So there are some description of the registers. So maybe it is much help to you to understand how the hardware spec is. And right now, the current status of the active streaming of original NuttX, there are many functions is already in original NuttX. And this upstreaming is by Arin-san here, and Ishikawa-san here. So very many thanks to them. So thank you very much. And also still have some function, especially the audio and GNSS, kind of the SU sensors. So this will be upstream, we plan. Okay, so that is just an overview. Please.
Just a quick question. So what are the lowest current consumption values then in sleep modes with and without the sensor power domain?
Sleep mode. If you, yeah, it's just if it's the sleep mode, the just remember, less than 100 microamp.
100 microamp.
Yeah, on the battery edge.
Fantastic. Is that with this sensor power domain off then? Yeah.
No, sensor power domain still remain.
100 microamp.
Yes. But it is just a chipset power consumption. Sorry. Yeah, it's only the chipset power consumption, not the board.
Sure.
Yeah. Any questions? Yes.
It's implemented cooperation between cores.
Mm-hmm.
Yeah, I'm not sure how that's.
What do you mean?
I think support in NuttX right now.
Yeah. This guy is using the FreeRTOS, and yeah, here I will explain it later.
Okay.
One of the 6 core is running NuttX.
Mm-hmm.
And I will explain why later on, but we didn't choose SMP software architecture because of the performance. I will explain that later on. Go ahead.
Do you have the slides with all the URLs?
You slide.
Second slide.
Second slide.
David send out the slides, right?
Yeah.
This one.
Dave, are all the slides
With web links.
Yeah. It's
Web links. Okay.
Yeah.
Here.
Providing none of the presenters have got an issue, then we will make all the slides available. Afterwards, we'll put them on the NuttX 2019 website. So if you're happy for them to go on,
Yes.
that's fine.
Okay. Go ahead.
Well, I did a quick search on the web, but I didn't see the chip itself on the marketplaces. Is it possible for us to buy the chip itself for small quantities?
I'm sorry. The MOQ is right now 3K. Yes. So yeah, we are discussing about MOQ more or less, more smaller with our sales guys, but
We'll push them into distribution.
yeah,
Let
yeah.
the distribution channel handle it.
Mhm. Okay. Any other question? Okay. So. Okay, so let's go to the hands-on. So I will demonstrate to 5 hands-ons. The first is NSH, the simple, how to say, simple one. And USB NSH is including the USB MSC actually. So and remote and this, and Wi-Fi with add-on board. You have it right now, and OpenCD IC It's just a demonstrate because you need some soldering actually on the extension board. So, but I will explain something. Yeah, this one is of course for you already using the NuttX guy is very simple, I think. But please let me explain that. But before that, I will explain the boot up mechanism of the 656002. So as I told you, the system processor is different core, Cortex M0F. And first, this guy is wake up by using the internal ROM code. And after that, this guy will access to the SPI flash, the upper partition I explained, and to get his own SPK file. Named loader.spk, actually loader.espk, sorry. And so after loading the loader ESPK and to start it on the Cortex M0 and to load the NuttX SPK. This is your own application. I will demo after this. And also the NuttX SPK is stored in the SPK partition, the upper layer I explained. And then the NuttX SPK start to run on the application processor, one of the 6 cores. That is a simple mechanism for boot up. So that's why before this board, before you use this board, you need to flash the loader SPK, ESPK, and also the GPS exists. So GPS, ESPK, you need to store. GPS is not mandatory, because if your application doesn't use GPS, then you don't care about the GPS core firmware. But anyway, before that, you need to store that. So first, let's flash the bootloader and the other binaries. So please go to the this website to download the zip file, packing the every ESPKs, including the bootloader. I will do that. So this is. So if you visit there, you can see the download firmware page, and please click that download now, and some the license. And if you accept, please press accept to download. So I'm sorry, I know that this part is not open. I'm sorry, yeah, because actually the loader, as I told you, that this is the core binary for the security on this chip system, and some product is already launched by using this chip. So so I'm sorry, but we cannot open that. And also the GNSS firmware itself is very proprietary. How to say, tips of the calculation of the position is inside. So also we cannot open that. But anyway, you can get the firmware itself from here. Sorry.
前のページに移った方が
前のそうかそうか。
リンクと
Yes,
わからない
yes, yes. Sorry. Sorry. Yeah. Here. And after finishing the download, then expand the zip files, and then there are 4 files actually inside the zip file. The loader is, as I told you, the loader, and GNSS and the GNSS. And DNN RT and the ASMP is kind of the algorithm by running on application, one of the application 6 cores. But okay, so and
it's still not
okay, so I will try to.
Anyway, I have one almost fresh. Yeah. You do the network.
So now you can get 4 ESPKs from the Spresense binaries v1.3.0 zip. And then you how to say? And downloading. So in the NuttX Git clone, there is a tools folder, and in the tool folder there are flashwriter.py exists right now, and this one will communicate to the Spresense main board to flash the SPKs. So first, please connect the main board to your USB to your PC like this, and the blue LED is lighting. This is a power LED, power existing power. Sorry, flashwriter the Pi. Subject. Oh, sorry. I missed the directories. Sorry, I will check. Now, here is NuttX directory, and
yeah, yes, right.
like this.
Yes.
Okay.
Yes.
So, tools flash writer.py is exists here. Here, here. So then NuttX in the NuttX folder, and after the accessing connecting here, connecting to the Spresense main board via the USB, then please execute flash, and -c is comport. So usually throughout dev TTY USB the okay. そういうことか。
Might be
Okay, yeah.
difficult. Yeah. Great.
Okay. I'm using the virtual machine. So. Okay.
Yeah, yes, right.
Dev TTY USB 0 for me. Maybe there someone is a different port number. And -b is baud rate. Default baud rate is 115200, but it's very slow. So 000 I recommend.
Yeah, yes.
And then to you how to say, file name pass to the SPKs from where, and there are you can the how to say sorry, how to say in English, you can put the multi names, multi SPK names here.
Yeah. I need to press some. Yeah. No.
Okay, so push. So execute this one. So then the please reset, and progress bar is existing, and the 4 files is flashing to the Spresense main board.
50. Yeah, 50. not maybe I see the new installation is
So if finished flashing, you can get Linux prompt, bash prompt back.
forbidding
Is it okay? Anyone to keep
I
this?
think some people need to install Pi serial.
Ah, I see.
Let me just wait a moment.
Sorry.
Yeah.
Yes. I see. Yeah.
Yeah. Maybe Python 3 serial.
No?
It's a lot.
I understand the installation.
Then do it yourself.
Can you type the comment?
Pretty sure.
Actually, a diff.
Yes, there.
Oh, okay.
Yeah, but I'm not sure how to talk with it. I tried to set it up and
How early you jumped into this new again, but in the early days, the concept was...
So I think some people need to install the Pi3 serial. So please install debug apt-get install the Python 3 serial to proceed. Yeah, Python 3 serial.
So you need, yeah, Masayo, maybe you need to type the comment.
Perhaps
sudo apt install Python
3 yeah, perhaps yes.
No, but serial, yeah. Yep. Maybe it's a little bit too.
Okay. Right.
already.
Installed Python 3
Spresense brush and share.
Yes, probably.
It only says the argument to argue, and then it's how to file. I could try to do it one by one.
The expansion of okay.
Yeah, fine.
The operating system.
Ah, yeah.
Yes, that's the MKSPK. It will be replaced later. Now, for now, it's done. And you need this.
I need it.
Yeah, just copy that line. It does the stuff for you.
I think it will not work.
Why?
Because there's this error when you clone something on this Wi-Fi from this company.
No. 5 minutes ago in the forest. The problem is on yours.
So maybe like this is the version of this.
Open the link in a browser and do a zip package and then unpack it. It's the same thing as to download it. I really have time to reach the proper thing, so. And you have to place it in that folder.
Okay.
So prepare by them. So I tried now. I changed the direction prepared by them. I figured it out. I try connect. Sorry, I will go to them. And how to do it because I perhaps like this. Waiting for the other connection.
There are instructions how
Run one line flash writer file with all files.
Okay, is it okay? Until here?
It did for
So next.
now it will
So
you have to build one.
the MK SPK2. This is two from the convert from the L file to the SPK file. This have to be downloaded to the tools in the tools directory of the NuttX. So let me show you. So right now the NuttX and tools and the cxd56 directory is here, and here is the repository. So please clone this repository on the tools in the tool directory. So right now here, this command is like this command.
So just put. Maybe you need to do disk clean first.
Oh, okay.
You already have a configuration in place. You have to do a clean first. Disk clean. Successful.
yes, sir.
Yeah.
Maybe you need some flash writer and just specify this NuttX speaker. Yeah.
Yeah, so after this file system, two repository is shown on Spresense 2's place. Then you can start the usual instruction to configure the board target and application, and build and flash to the NuttX SPK to the target, like this instruction. Okay, first let me try on Spresense. So first, bring all the things. And configure sh Spresense and sh. Yeah, then just make very simple.
M0P is not valid.
Sorry?
But I can do it with other. Yeah, right now it's okay. He's got his prompt.
So, okay, someone see the message when you bootloader installed. The M0P has no valid bootloader something. That will be removed after flashing the NuttX SPK. So please keep it away, and please continue to build the NuttX SPK and flash it to the target. So if you use the if you success the build, then the message generating the NuttX SPK, the file NuttX SPK is successfully created. So this message is a success message for the build. Okay. And then the tools, brush, I would say same I would be NuttX SPK. So it's the same way as like ESPK's the bootloaders. Just the difference is last one is NuttX SPK. So actually, so here is a NuttX directory, and the file NuttX SPK exists here. And flash to the
Ja, die heb ik al.
Is that okay?
Maar kijk, ja, ik weet niet of je dat even wel.
So then the same progress by starts, and that is SPK. Okay, then it's already flashed everything what you need on the Spresense. And for example, we need access to the console. So the NuttX prompt exists just this one using this debug interface. The NuttX.
Yeah, that's quite simple.
Okay.
Yeah. Oh man, you need all this, you need for everyone to probably to I have an extra.
Okay.
Ja, he flashed the board for the other ones, so I tried to do SPK.
Yeah, 1.5 Mac.
1.5 gigabyte.
Yeah. I'm catching up. I'm catching up. 60.
There's some strange characters inside it. Hey, oh, this is a zero to much.
It even says a date.
Yeah. It's, I think it's okay.
Actually, because a USB doesn't matter.
I also need some books to
Does the USB and SH, you also open that one? Okay, 30 seconds. No, like
I just typed it in again. Instead of copying it from the PDF file. That's a mistake I sometimes make, and then there's a hidden character somewhere.
Maybe the Japanese character is. Sorry. Yeah. I see. I understood. Okay. So. Yeah, any terminal software you can use of course. I'm very
that's why
it's like minimal, but okay. So that is a basic way to use NuttX on Spresense. And next, maybe it takes more time and 40 minutes less. Yeah, this one is almost the same way, but difference is using the extension board. And this extension board has a SD card slot here, and please put your own SD card. And then and also here is one another micro USB connector. This connector is connected to the 65602 directory. Then if you execute this instruction, then the NuttX is using the USB for MSC, a mass storage class library, and then the access after piece access connect to the micro USB on the extension board. Then the PC can access to the SD card directly via the Spresense. I will show you exact example. So first, make this screen. And configure Spresense USB and SH and up to one app directory and make. Sorry. Sorry, this is misdescription. Sorry, this is a USB NSH. Sorry.
No. Yeah, I have them. This is good. Yeah, that's there. But if I then have this package, right?
The USB MTP also works.
It right now works.
Yeah, the MTP works.
Okay. Okay, so the NuttX SPK successfully create again, and then the flash the binary.
Okay, then that's probably a local thing. No, I don't have. don't have this
And then the board, extension board and the main board should be connected. And this main board has the kind of the silver bar. And if you see the top the board on the silver bar, then the SD card upside like this direction, and then the connect this B2B connector and the B2B connector can access here. Yeah. And then you need two cable. One is for the NuttX terminal here, and one is for MSC here, like this. Two cable. And then the access. And MS.com here. Yes.
Yes. Yes, yes, that's right. That's you.
Okay, and MS.com command is, as you know, the enabling the master range class access from the PC. And after this, you can see the storage.
Because if I
Here. Right now, my SD card has audio being some directories and temp here. And on the NSH side, the SD card is mounted on mount SD0. So you can see the same directory on the PC via the MSC. And if you add some directory, some file, some folder, for example, here. And M2 file exists. So this is kind of the USB NSC, NSH.
And they made
Okay.
This one, there is a
Okay ですか？いいですか？ Yeah, actually the almost the same game, but okay. Next, let me go to next. Next is the Wi-Fi. Please, I tried Wi-Fi before. So the remote end is just like USB mass storage class. The difference is just the network card looks like network card. So I will explain it. First, the remote end is jump and to the Wi-Fi add-on board. How to use the Wi-Fi add-on board first, I will explain. So the pin package, pin plastic bag, I give you. Please add the on the main board here, and if you see this direction on the board, the silver bar is here. Silver bar is here, and the Wi-Fi board is just upside of the on the main board, but the CE mark is upside down. Okay.
Antenna up or down?
Yeah, CE mark is upside down. CE mark on the Wi-Fi board is upside down. So, so it's difficult to see. So this picture is look like this way. Yeah, the SD card. So this way and upside down CE mark this way and the top of the this connector.
Can double check that.
Oh, je hebt geen detector.
Maybe we can pick a picture.
Yeah.
Okay, so for this, the Wi-Fi board is the driver is ported as a user socket mechanism of the Spresense, or they have, and then the instruction is almost every time the same, but Spresense Wi-Fi. Please configure the Spresense Wi-Fi like this. Tools. On configure.sh Spresense Wi-Fi. No, before that, please make this screen.
Maybe we should explain because those people could.
Yes.
I can suggest maybe it's better to explain this until need to be in the same position because some people are looking it inverted.
It's opposite. Yeah. This is yes.
Can you please to double check?
Okay. This one is.
Yeah, you're correct. Sorry. He was incorrect. This one was
Sorry.
What is the correct way?
He was
Yes.
correct.
Yes.
Okay. Yeah. So I was correct.
Mas ele was incorrect.
Yeah, and this is according to your also according to
That's how I
This one, right?
The boards do have like a pin 1 marking on them, both boards. And if you align them, that is correct.
Yes. Okay. So after this screen, tools, configure again, Wi-Fi. Okay, and make again.
Try to increase a little bit more.
Yeah.
Yeah.
Here.
Yeah. It's like unsafe. Pin 1 is with pin 1. Yeah. Sorry. No problem.
If anyone confusing the connection, I will show you my board as a reference. Is it okay? Anyone else? Yeah, it looks okay.
yeah.
Yes. Thanks. Okay.
Okay. Wi-Fi. Wi-Fi, yes. Spresense should work.
Is that it?
So then the axe flash to the presence not SPK again.
En dat is ja,
Is there any more than okay?
Okay. So after this, you need to activate the Wi-Fi board as a AP mode by using the command. Okay. For example, first access here and help. If you type help, there are five example the building command and GS 2020-200M is the command for the Wi-Fi board. And GS2200M -A. This is indicate AP mode, and after this, you can select your Wi-Fi RF channel from 1 to 11. So, for example, 1, and after that, your unique SSID. Okay, and my name is Takayoshi, so Takanet, for example. And after that, this the web password, 10-digit number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, for example. Then it should be work as a daemon, so ampersand exists. So now the GS2200 is stable. So then you can see the Takanet here, network. Yeah, okay, let me show you the next page. So how to execute? So execute GS2200M is a command for controlling the Wi-Fi board. And this command using with -A option is execute as AP mode. So on this demo, please execute GS2200M space -A space and channel number of the AP Wi-Fi AP from 1 to 11. You can select anything. Maybe everyone using the one very very busy channel, so you can use 2 or 3 or until 11. You can choose, and after the number, you set your own SSID of your AP network. And next is 10-digit password number for your access to your application process, AP access point. So, for example, 10 digits, so 1 to 0, 1, 2, 3, 4, 5, 6, 8, 9, 0. And ampersand. It's a user software. It's a kind of mechanism of the user socket on NuttX. Yeah. It looks like the BSD socket behaves, but the network stack and network protocol stack is not on NuttX.
But the program doesn't do anything special, just
to the model. Yeah.
Very nice. Congratulations.
Okay, and then you can now your access point is available, so you can access to the access point. So now I see the Takanet, so access the Takanet, Now it accessed. So
Gewoon een YouTube uitzoeken.
So NuttX, the network is right now the local address 192.168.11.1, and on the other hand, how to say? So right now, this address is available from the PC to the NuttX. The ping is passed, and on the NuttX, so there is a web server. So start a web server here, and using the browser to access here. Then you see the SD0 files, and you can get the file list via the web server, from the web server. So address is just the same address as okay, so this one is right now this guy is the access point, and this PC is access to this access point, and then we have a connection of the network, Wi-Fi network right now. So for example, execute the telnet daemon on the device side, and access with the telnet. So you can see the nutshell via the network also.
Dat is 50k. Dan moet je het even weten.
Like this. Okay. So actually this work is very helpful from the Ishikawa-san, actually. Yes. Thank you very much. So, okay, so 10 minutes. So, okay, I will, can I proceed? Or could you access to the access point?
No, I got out of sync with the Raspberry, so I can try that as well.
Okay.
It's better that I follow you.
Okay, and OpenCD is usual OpenCD. I will pass this one. Sorry, almost because 10 minutes. So you know the usual. This one is ARM Cortex M4F. So the J device is supporting, and actually, so extension boards on here, there is a LAN for the JWX pin header, but sorry, it is no mount from the shop, so you need to solder to pin, make the pin on here. And after using this soldering this pin header, then you can use J device supporting the CMC stack protocol. So on our webpage, we recommend K-Link 2 or the NXP LPCA Link 2. But also you can use any other ICE device supporting the CMC stack. So actually, in my case, I get usually I'm using the Ulink ME also. It's almost not buy right now, I'm not sure, but yeah, it's very good for portable, so I like this one. And the access connected to here, the pin header here, and use access to the OpenCD. And let me show you some the Spresense SDK side. This function is still not merged on the mainline yet, but this is what exactly a difference special for Spresense Board. So let me explain you. So the Spresense SDK is, as I told you, built based on NuttX version 7.22, very old, almost 3 years ago, around, and 2 years. Then in this Spresense repository has two big parts. One is NuttX itself. It's as a kernel of the Spresense SDK, and the SDK directory is for special implementation of the Spresense. And this after this, I will explain some demos from source code build. So first, I explain the audio player. So Spresense has an audio input-output functionality. I explained, and software stack is like OpenMax. Sorry, it's typo. OPEN Max. Like there are many audio components, media components, and combined gathering the data flow. Then you can get some application of the media. So for the audio player, using the media player object and output object, and right now the current supporting codecs are only MP3 or WAV file. The encoding and decoding also is supporting. And in this demo, Spresense play the MP3 file. So how to do that? First, we make in the Spresense SDK. There are two parts to build. One is the NuttX kernel side, and one is the SDK side. The kernel side, the reason why to split the two parts is NuttX kernel is almost fixed, not so much configured anytime. So that means build is one time we build done, that is not configured again. That means reconfigured, then the build again, because config.header is modified. So I would like to avoid that. The NuttX kernel build is first, do that, and then the SDK side will be configured and built. So first, Spresense SDK directory on the Spresense SDK directory by using the tools configure.py. It's not like the config.sh, but it's a different Python tool. And -k means the kernel size. And the kernel size, you can choose release and debug configuration. So the please release configuration, and then the build kernel by make space build kernel command subcommand, and then the NuttX side is build, and after that you use the SDK side with audio player example. So the example code is in Spresense examples audio player, and then the configured by using the same command, but option is different. Example audio player space, and we will use SD card for store save the MP3 file into the SD card. So use SD card here, and make this one is not enough for because mastery's device command is not included. So please use menu command or gconf to enable the MS USB masterage. Okay, this I will just show you this one. 2 minutes. In 2 minutes. Okay.
You're standing between these guys and beer.
Okay, just a moment. So Spresense SDKs first. Here tools configure.py -k and release. So by the way, if you how to say, if you source the build m.sh, then you can 保管なんて言うんでしょう。config.py -k space. You can use a tab to show the candidate. Then release and make build kernel. Just a moment.
can do this one and then we finish, and then because I think we can carry this on tomorrow afternoon because some people lost their way. So.
Yeah. This is I made the final. And here, example. Sorry. And the device and make.
So what we'll do, guys, it's all guys, I guess. What we'll do is we'll just get this one capped off now, and then we'll finish for this evening because I think it's been a very long day for everyone. And then tomorrow afternoon, it was one bit of decent scheduling, I guess. We put an open hacking session in there because there's some new toys, and obviously these boards we can do more work with. And also the chance for some open interactivity, which I'm already seeing going on anyway. So tomorrow afternoon we will pick this stuff up again, and there'll be a test at the end.
Yeah. So after finishing the build, the same file named NuttX SDK is this. Created, and then if how to say and some needed file stored on SD card, and then you can play the music.
There you go.
Like this.
Okay.
Yeah. Okay.
We're done?
Yeah, that
right.
is, sorry, and thank you very much for attention.
After